In this video, we want to evaluate the integral x times x plus 5 to the 8th. And I'm going to do it using integration by parts and also a U-substitution. Now you could also expand x plus 5 to the 8th and then multiply by x and do it term by term. But that gets kind of tedious. So I'm going to let u equal to x, because if I differentiate that, that gives me a 1. So that simplifies it. So that this u equal to x, then du will be 1. That will be dx. And then my dv will equal to x plus 5 to the 8th. So we've broken up this integral in two parts. So dv is x plus 5 to the 8th power. And this will be dx here. So I integrate the dv, that'll give me v. And this is pretty much the same sort of thing as if you had x to the 8th, because the derivative of x plus 5 is 1. So if I did a u substitution here, it would just come out to this. So this will be x plus 5 add 1 to the exponent, be 9, and this will be 9. So you can check it by taking the derivative. This will be 9 times the coefficient, the 9's cancel out, subtract 1 from the 9, we get the 8, and the derivative of x plus 5, that's your chain rule, is 1, gives me the same thing to start off with. So then we're set here. The formula tells me then it's going to be u times the v. So this is x then, is your u, and the v is x plus 5 to the 9th over 9. So u times v. And then it's next part of the formula, it's a minus and it has an integral. And the first expression here is v, which is right here. So this will be x plus 5 to the 9th over 9. And then the next part is the du, which is just dx here. When I rewrite this then, this is equal to, we got x and x plus 5 to the 9th. And then again, this is kind of like the same thing if you had x to the 9th, because the derivative of x plus 5 is 1. Now this had a 2 here, would be different. So to integrate this expression here, I just add 1 to the exponent, the power, that'd be a 10. Then bring that down here. So this will give me a minus. I'd have x plus 5 to the 10th. The 10 comes down here, gives me a 90 here. And then it's your constant of integration. And that's pretty much it. This is your answer using the integration by parts formula. Of course, I got the 9 here. Now when we do it by the u substitution, the answers aren't going to look like this. It'll be a little bit different, as it happens sometimes when you do a different method. But you can always check your answer. So let's go ahead and do this before we go to the next method. So to check it, I take the derivative of this expression. This is the answer. Take the derivative of this expression here, the answer, and I should get this integrand here. So let's do the first part here. So let's take the derivative of this here. So this is x times x plus 5 to the 9th over 9. Because we have two expressions involving this, we have to use the product rule. So let's do it this way. It'll be x times the derivative of this expression here. So I would bring this power here, 9 times the coefficient, the 9's would cancel out, then I subtract 1 from the exponent there, I get 8. So this will give me x plus 5 to the 8th So again, it's the x times the derivative of the expression here. And then it's plus the second factor expression, and it's x plus 5 to the 9th times the derivative of the first part is x is 1, so this gives me this. So I got this. And then for the second part here, take the derivative here. Don't have an x in front, so it's just a regular 10 comes out in front, and then 10 reduces at 90 to a 9, so I get a minus. Subtract 1 from the exponent, gives me x plus 5 to the 9th power. And this is over 9. And notice these are opposite here. X plus 5 to the 9th over 9. X plus 5 to the 9th over 9. And this is a minus here, so these cancel out. And I'm left with x times x plus 5 to the 8th. So this one checks out. So again, this is your answer there. Now let's see the U substitution. So for the U substitution, I'm going to let u equal to x plus 5. So du, derivative of x plus 5 is 1, so this would just be du equal to x, dx, I should say. So du equals to dx. So I come back over here then. So this part here, x plus 5, that'll be the u. Now I need a substitution for x. So from this right there, I can solve for x. So if I bring the 5 over to the left side, x will equal to u minus 5. Now I can substitute and convert this to an integral involving the variable u. So again, x is u minus 5. Make that substitution. And x plus 5, that's your u. So then I got u to the 8th power. And of course, dx is du. And then I just multiply through by u to the 8th here. So u to the 8th times u gives me a u to the 9th. And minus 5 times u to the 8th. With this. And then we just integrate here. U to the 9th, integrate with respect to u. We just simply add 1 to the 9. That gives me a 10. We divide by 10. And the next one, minus 5. Then add 1 to the 8. We get u to the 9th over 9. Plus the constant integration. And then we just go back to the original variable. So that means then replace the u. All we have to do is replace the u by x plus 5. So the final answer then would be x plus 5 to the 10th over 10 minus 5/9. Then the u again replaced by x plus 5 to the 9th plus the constant integration. And then this looks different than the first answer. We'll look at both of them together in a minute here. But let's check to see if this one is really an answer. Get this out of the way here. So using this method here, then the solution, or the value of the integral, is x plus 5 to the 10th over 10 minus 5/9 multiplied by x plus 5 to the 9th. So let's check it, because it is different than the answer using the integration by parts. Take the derivative here, so 10 times the coefficient here divides at 10, so I get x plus 5. Subtract 1 from the 10, we get 9. And of course I'm not doing this, but we have to do the derivative of x plus 5. That's your chain root, but in this case it's 1. So it doesn't affect it, but you don't want to forget that, because if this had been x squared and I don't take the derivative of the expression in the parentheses, then it would be incorrect. So we get this, and then for the same thing for the next one, derivative here, 9 times the coefficient, cancels the 9, this will be minus 5. And then this gives me x plus 5. Subtract 1 from the exponent, that's 8. And again, the derivative of the expression here, using the chain rule, this is just 1. Derivative of a constant, of course, is 0. So we get this. We want to show that we get this right here. So let's factor x plus 5 to the 8th is common there. So say x plus 5 to the 8th. And what does that leave me? So for the first one, that leaves me with x plus 5. Okay, taking out 8 factors of the x plus 5 leaves me with 1 factor of x plus 5. And then it's minus 5. Whereas here we took everything, x plus 5 to the 8th, so that just leaves me with minus 5. So I've got 5 minus 5 cancels, leaves me with x. So what do we, I'm left in with just an x times x plus 5 to the 8th, which is the integrand. So it checks out. So now let's have a look at the two answers we got. Using the first method, integration by parts, this is what we got. Yeah, it's kind of similar. You see the x plus 5 to the 9th, x plus 5 to the 9th, x plus 5 to the 10th, and so on. But you wouldn't say it's the same thing. But they are, just written in a different form, and we can. And you saw that we checked both of them, and they both work. So either answer is acceptable. Thanks for watching. We'll see you next time.